Hi, my name is Jolie Stokes, and this is my lab report for the Lab 1 Charge Tapes, Physics 2212. As a brief introduction, in this lab, we were able to explore the properties of charge, force, and electric fields, stimulate real-life examples of objects acting on one another, and gain a further understanding of net electric forces. As an overview, we used clear tape to approximate the magnitude of the charge on a charged tape. We used different items such as charged pens to draw conclusions about the signs of the charge on the tape, and some of the fundamental principles we used were Coulomb's law, which is that force equals 1 over 4 pi epsilon naught times the charge of 1 times the charge of 2 over the distance squared. We also used Newton's second law, which states that force equals mass times acceleration. By the end of this lab, we were able to conclude that there's a positive charge on the two pieces of tapes that result in the repulsion when brought near each other. The electric charge on a single piece of tape is 1.137 times 10 to the negative 8 coulombs, and the tape has lost 7.12 times 10 to the 10th electrons. In this experiment, we assume that air resistance is ignored on moving tape. Tape is considered to be a point charge with the tested charge located at the center of the tape, and that each U-tape has approximately equal charge distributed throughout the area of the tape. We'll move into our experimental data and our models. So we have some baseline information that we get when doing observations for this lab. So the first is that the U-tape was attracted to our hands, and that U-tape 1 and U-tape 2 repelled each other. U-tape 1 in the neutrally charged book showed attraction. U-tape 1 in the negatively charged pen showed attraction. And so we can conclude that both U-tapes have a positive charge. We measured the tape mass, which was 1.9 times 10 to the negative 4 kilograms, the tape length, which was 0.2 meters, and the tape's width, which was 0.015 meters. We were given the atom's length of 1 times 10 to the negative 10th meters, and gravity, which is negative 9.81 meters per second squared, along with the charge of an electron, which is 1.6 times 10 to the negative 19th. We can also see on our model that our source, which is where the charge is coming from, is our U-tape 1, which is on the bottom, and our system, which is U-tape 2, is on the top. The K constant is given as 9 times 10 to the 9th newtons times meters squared over coulomb squared, and the distance between our two tapes when they began to float was 0.025 meters. Here are our calculations of our observed model. The magnitude of the gravitational force was found with Newton's law, which states that force equals mass times acceleration. We can also assume that the force of the electrons equal the force of gravity because the tape floats, so there's a net force of 0. The charge on the tape was found using Coulomb's formula, which we rearranged to solve for Q, which is the charge of the tape, which ended up being 1.137 times 10 to the negative 8th coulombs. We also found the electrons lost on the tape by dividing the charge of the tape divided by the electron charge. And lastly, we found the ratio of electrons to atoms by first finding the tape's area, then the atom's area, then the atoms on the tape, and then use the ratio, which is 1 atom to every 4.21 times 10 to the 6th electrons. We'll look at a code written in GlowScript to present a conceptual model of what's happening with the forces in the lab. So using GlowScript to do calculations, the source, which is U-tape 1, is represented by the dark blue particle at the bottom of the screen. The system, which is U-tape 2, is represented by the cyan particle. The gravitational force is depicted by the red arrow, which points in the negative y direction, and it acts against our electric force from U-tape 1, as depicted by the yellow arrow, which points in the positive y direction. To conclude the lab report, we'll discuss the possible sources of error that may have resulted in discrepancies in the results of our lab. So possible sources of error may have come from touching the tape with our hands that may have caused a loss in charge. The weight of the tape was calculated as a fraction of the mass of the roll of tape rather than being weighed on an actual scale. The tape is not actually a point charge. There are many charges acting on one portion of the tape at once, but we use point charges to simplify the system. We also did not account for outside charges, and the charges of the tapes were likely not equal